The organic chemistry question, you can see the structure of 5 alkenes are there, A, B, C, D, and E, as shown. What is the general formula of alkene? The general formula, the number of the hydrogen are twice as compared to number of the carbon. So it's a CnH2n. And remember, cyclic alkanes have the same general formula as alkenes. Like if we have a cyclic alkane, the alkane which does not have any end, so the number of the hydrogen and number of like hydrogen are always twice. So cyclic alkanes and alkenes, they have the same general formulas. The next question is, what is the molecular formula of a compound D? What is the molecular formula of compound D? Molecular formula means like how many carbon atoms for compound D? 1, 2, 3, 4, 5 are there. So C5 and H, definitely it should be 10. But what if in the exam they ask what is a structural formula of compound? Like that is correct what you wrote. But what if the question was what is a structural formula? So how to represent a structural formula? In a structural formula, like we write carbon and hydrogen like a group. So CH2 is one group. So this CH2, then CH, we don't show the bonds. Then CH2, then CH2, and then CH3. So this is a structural formula of this compound. But usually they ask molecular. In a molecular, we represent. In a displayed formula, we show all the bonds and all the atoms. Predict which alkane will have the highest boiling point and explain your answer. E, what is the reason why? Because they have a weak intermolecular forces, and these forces depends on the number of the atoms, number of electrons available. So highest number of the carbon, longest carbon chain, because for organic compounds, the boiling point increases as more carbon atoms are there. So it has the longest carbon chain, that's why it will have the highest boiling point. Why, which alkane A to E diffuse most quickly? Which is likely to diffuse most quickly? A to E. So A, and why A is likely to diffuse most quickly? Because it has the lowest melting point, lowest relative molecular mass. Then a student added an aqueous bromine. What is the color whenever aqueous bromine is added? So aqueous bromine, initially it's orange, it will be colorless. Then what will the product look? Remember, whenever we add aqueous bromine, describe the color change and draw the structure of product. So if I add Br2 to this, what will happen? The double bond will turn into a single bond and bromine added to both carbons. So what will the product? It will be C, H, H. We break the double bond. We can draw as it is. But we have to show all the bonds and all the atoms. So I'm not supposed to write CH2 and CH3 here. I have to show them that they are bonded. So this will be CH2 and this will be CH3. And this will be H. Now, what will happen? The double bond will break and the two bromine atoms bonded. So this will be Br here, another Br here. Or you can attach up or down, as it does not make difference. You can attach Br here or Br up or down. But because whenever bromine is added, the two atoms of a bromine each added to the carbon which is having a double bond. Two different alcohols can be produced from this alkene by an addition reaction. Draw the structure of two alcohol. Look, whenever it will react with steam, so what will happen when it reacted with steam like H and OH? So first, what is the first possibility? Hydrogen might be added to the first carbon and OH added to the second carbon. So what is the first possible product? The first possible product is like one will have a hydrogen attached, another one will have OH attached, which is propane 2-ol. OH I can make it up or as well, draw it up. And if I all the bonds I have to show, if I write OH, then it is not correct because I have to show even the bond between oxygen and hydrogen. So this is one possibility. The second possibility, what might happen, that when H and OH are there, so OH might be attached with the first carbon and H attached to the second carbon. So the second structure, you break the double bond. And one side will be OH and one side will be H, which is propane 1-ol and propane 2-ol. So whenever alkenes react, the double bond break and turn into a single bond. State a reagent and condition needed to produce an alcohol from alkene. So reagents, propene and steam, and the condition. We need heat and 200 degree and phosphoric acid. That's right. Because alkene B is what? So this is alkene B, which is propene. So propene plus steam, it will give propanol. Alkene C can be converted into a polymer. What type of polymerization happen in alkenes? So it's always addition polymerization. Suggests a name of a polymer form. So if this is propene, so the polymer, just you have to name the term, add the term poly. So this will be polypropene. Sorry, if this is butene, sorry, I was listing a B1, that's right. If this is butene because 4 carbons are there, or but1ene, then it will be polybutene. Then you have to complete the structure whenever the same structure you will draw, but you will break the double bond. CH2, CH3, and N. This is the equation, and don't forget to put a bracket and N. If they ask in exam to draw polymer, then you have to put bracket and write N. But if they ask for the units, like draw 1 unit, 1 repeat unit, or 2 repeat units, in that case, you don't have to show the value for N. Like you don't have to put a bracket or write N there. State empirical formula of the polymer. Monomers and polymers of alkenes, they have the same empirical formula. So what is the empirical formula of alkene? It is CH2. So the polymer will also have the same empirical formula, which is CH2. Because this is just an addition. Part of a structure of synthetic polymer, state type of synthetic polymer. What kind of polymer is this? You can see the carbon chains are linked. Is it addition or condensation? So this is addition because it's linked with the carbon. If it was condensation, then it might have amide linkage or peptide linkage, or it may have the ester linkage. It is not condensation. This is wrong. It cannot be condensation. Why it cannot be condensation? Because condensation polymer, they should have amide linkage or peptide linkage or ester linkage. But you can see the carbon chains are linked with each other. So whenever carbon chains are linked with each other, then it will be addition polymer. Deduce the empirical formula. Empirical formula will be same as the monomer. So it will be CH2. Draw the structure of a monomer. How to draw the structure? When you have a addition polymer, just take the first 2 carbon atoms and hide rest of them. So take the first 2 carbon atoms and hide rest of them. And just draw the double bond. So this will be the polymer. So this will be the monomer. The polymer is given, and whenever in exam you need a monomer for addition polymer, just take the first two carbon atoms and hide rest of them, and just put a double bond. This will be a monomer. The formula C4H10 represent two different structural isomers. What is meant by structural isomers? So definition of isomer, structural isomer. So they will have the same molecular formula, but they will have a different structures. So same molecular formula and different structure, we call them as structural isomers. Draw structures of two structural isomers of C4H10. And we have to show all the bonds and all the atoms. So C4H10, we draw 4 carbon atoms in a straight. And if you want to make a branch for alkanes, if you want to make a branch, you cannot make a branch with the first or the last. Branch is always from second to the second last. Then this will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogens. And this will have 3 hydrogen. This will have 3 because one bond is there. This will have 1 hydrogen. This will have 3 hydrogens, and this will also have 3 hydrogens. All structural isomers of C4 are flammable. Incomplete combustion. So incomplete combustion, it should produce carbon monoxide or it can produce unburnt carbon. So C4H10, write a chemical equation. So we want a full equation for this combustion. So C4H10 plus O2 gives CO plus H2O, or C plus H2O, you can also say that, or C plus CO plus H2O. When we balance the combustion equation, start with oxygen followed by hydrogen and then any other element. So oxygen is 2, balance. Then we have to, the combustion equation start with carbon by mistake, because this is for other equation, but for combustion equation, carbon, hydrogen, and at the last oxygen. Carbon is 4, so we put 4, carbon is balance. Then hydrogen is 10, we put 5, so hydrogen is balance. 5 multiplied by 2 makes 10. What about oxygen? 4 here and 5 here. So we need total 9 oxygen. So how can we can have 9 oxygen? So we can write 9 by 2. So it is right, like you can mention a fraction to balance them. Even like in a marking scheme, multiple answer will be there, as incomplete combustion can result. Like this 9 by 2 is the same thing. If you write, as I wrote this equation, because this 9 by 2 is same as what is written in the marking scheme, because what they did, they multiply all of them by 2. So this will become 2, this will be cancelled, this will become 8, and this will become 10. But even in exam, if you leave it like 9 by 2, that is also correct. So these are the questions from organic chemistry. Any question or doubt related to the session?